Hi, I'm Yoyo, a PhD student at Cornell University. I work with Professor Malte Jung in Robot in Groups Lab. Today I'm going to present my paper at CSCW 2021. Before I jump directly into the paper, I'd like you to imagine a scenario first. Say if you have some money and you want to invest in two companies, Company A and Company B. Your first plan is that you split your money 50-50. But then a stranger just gave you a suggestion saying that you should put more money in A instead of B. Will you listen to this suggestion? If this is not a stranger, but a very famous financial expert, then will you listen to this suggestion of investing more in A? And now imagine that if the suggestion does not come from a human, but a very advanced AI system, and this AI system tells you that you should invest in B more comparing to A, then will you listen to this suggestion from the AI system? Now you probably have a sense what I will be talking about in this paper. I'm talking about the expertise level matters, and I'm also discussing whether the suggestions coming from the AI system or the human. With the advance of AI technology, we are seeing more and more this kind of AI systems that make suggestions and help people make decisions. These systems are used in a lot of scenarios, such as resume screening systems, and also in hospitals, they help doctors to make diagnoses. So in short, these AI systems takes the decision support roles traditionally held by humans, and they are competing directly with human intelligence. And this leads naturally to a question. Are people more influenced by suggestion from humans, or are they more influenced by the suggestion from the AI systems? These seemingly straightforward questions actually have yielded two streams of different studies. One is algorithm aversion, the other one is algorithm appreciation. For algorithm aversion, they want to find out what's people's response to AI, because they find out that AI usually has better performance than human in decision making. But then their finding is that people are reluctant to accept suggestions from AI systems. So they called it algorithm aversion. On the other hand, the streams of studies in AI appreciation found out the opposite effect, that people actually adhere more to suggestion from AI systems and not from the humans. So there is absolutely a conflict between these two different streams of studies. And is there any problem with this conflict? The answer is yes, because they give different suggestions to how to increase the use of AI systems. The streams of algorithm aversion, because they think people don't like suggestion from algorithms, so they suggest that we should emphasize the human touch of these suggestions so that people accept it better. However, in the streams of algorithm appreciation, because they think people already prefer suggestions from AI systems, so to increase the use of AI systems, you just make them more obvious that it's from the AI systems and not from the humans. As researchers, we are interested in what caused the inconsistency between these two streams of different studies. So we look into the studies, especially the experiment design manipulations of different conditions. And we found some interesting and systemic trend. In studies with algorithm aversions, the description for the human condition is often expert or physicians. However, in studies that find algorithm appreciation, the description for the human condition is often participants or even randomly chosen participants. So that makes us to speculate, is this a cause of these two different streams of studies? Will it be possible that the framing of different conditions can be one important factor here? Here by framing, we mean how the condition, how the AI system and the human are named, like what terms are used, and also what description were used to describe these two different conditions. To investigate it into the problem, we did 3 experiments to test it. Here I'll just introduce the first 2 experiments. In experiment 1, we hope to set up a baseline of algorithm aversion or algorithm appreciation. So basically, we recruited 120 participants all over mechanical MTurk and run the studies on Qualtrics, which is a 2x2 study. The first two is the agent type, whether it's from an AI system or it's from human. The second two is the task type, which we will not discuss in the video, and the details are in the paper. After these people are recruited on Amazon Turk and they are on Qualtrics, they will need to do the decision-making task. The decision-making task basically is repeated 4 times because 2x2 4 conditions. And first, in each condition, they are first paired with a suggestion giver, which will be an AI or a human. And the description for the AI is AI, which scored higher than most of the participants in a previous experiment. And the description for human is another MTurker who scored higher than most of the participants in the previous experiment. Remember that experiment 1 is just baseline, so we just use a random description for these 2 conditions and keep them the same. And for each question, they need to submit their answer first, and then they will see their answer along with the suggestion giver's answer. And then after they see the suggestion, they can decide whether to adjust their answer or not and submit their final answer. And therefore, we can calculate how much the participants were influenced by the suggestion giver by simply looking at how much they changed from their first answer to their second answer, and which is usually 0% to 100%. 0% means that the participants did not change their answer at all, and 100% means that they just aligned with the suggestion. And the result of this baseline, we found out in experiment 1. People prefer suggestion from the algorithms, like from the AI systems, than from humans. So it is clearly an algorithm appreciation effect. But what is most interesting is experiment 2. Because experiment 1 is just a baseline, and we found out an algorithm appreciation effect, in experiment 2, we hope to do the opposite. So we try to decrease the influence of the algorithms or the AI systems, and we try to increase the influence of the human. So we change the framing, and everything else remains identical. Only framings are changed. Now the description for the human is a group of experts who formulated these decision inputs with their 20 years of experience in art education and creativity. And now the description or the framing for the algorithm or the AI system is an algorithm, which was created by aggregating several MTurkers' response in a previous experiment. And the result, we successfully reversed the result. Now, the people prefer suggestion from the human condition compared to the AI system condition, which is clearly an algorithm aversion effect. So to sum up, in these 2 studies, these 2 experiments are basically identical except for the framings. But we can create in experiment 1 an algorithm appreciation effect, and in experiment 2 an algorithm aversion effect. So what matters is not whether it is a human or an algorithm, but more important is what kind of human and what kind of algorithm you are comparing. So our conclusion is the framing really matters. And it is probably more important than whether it's really a human or it's an AI. And that's roughly it. I hope you enjoyed this video. We try our best to cover the most important parts in our paper. But please read our paper because it contains more detailing analysis and also other topics. We also discussed what is the underlying factor behind these different framings, which is expert power. We also introduced the theory of power and how the power theory can be used in CSCW community. Thank you again. If you have any question, just feel free to ask us. Thank you very much.